And then it's super loud.
Screaming, and I was like, oh my goodness.
It only goes so far.
You need like a little clip.
I had one. I had a Bluetooth thing, but one, it was annoying to wear, and two, it kind of like was like a buzzing sound. So like when you watched the video, like yes, it was always there, but there was this like buzzing in the background. I need a better one. I don't know.
Are you recording talking about this right now?
Yep.
Actually, whenever you walked away, I heard Nathan better. Sorry.
I think you should definitely write this down here, but it's up to you on how much other stuff that you write, depending on what you remember about domain. If you don't remember anything about finding domain, then you might want to write it all. But yesterday we talked about that domain is the x values, or like what you start with, the input of the function. So when we're talking about domain, we want to know what x values are allowed. So this is kind of just me like kind of getting you ready for domain. So I don't know if you really need to write that stuff, but it says, oftentimes the domain of a function is not specified. All they give you is an equation. Like yesterday, is this a function? They just give you an equation. And so what we want to learn to do today is, if I give you an equation, I want you to be able to give me the domain. So maybe I'll move up down to this one. So this definitely the bottom thing you should write. The domain of f why you can't hear me. I should move this over to this side because I always like to stand right here.
I was like, about halfway through, I was like, just walk to the podium again.
What if I use this? This is what I do when I'm going to be absent and I record. I move my podium right here, and then I put this right here, and then I just talk right here to this with my book right in front of me. And then this happens. Did this happen yesterday? Oh. And then it's really super loud if you watch that on the recording, because you have the volume up really loud, and then you're like, oh my gosh, she just died.
I turned YouTube all the way up, and I turned the computer all the way up, and then I thought, go get my headphones just so I can actually put them in my ears to actually hear it.
I'll do better. Sorry. Only now. Can you see you're on this? I'll just go with it. Ready? Sorry.
Mine stopped in the same spot. Came up just a little bit.
The domain is the largest set of real numbers for which the value of f of x is a real number. When I teach this in Algebra 2 or Pre-Calculus, I always say to find your domain, it's usually easiest to think about what x is not allowed to be, and then everything else is your domain. So let's look at a few of these, and hopefully we'll kind of see a pattern emerging. Are we done writing this? Not done writing this?
I just remembered.
See, people always tell me not to stand over here with all these cords, but I have to for the microphone.
How far is the microphone? What's the all tangle? What is she holding with the balloons?
I got confused by the blue one. I don't know. I can't do this right now. We have to learn. I'll just put it in like on a lanyard, and I'll just have it like this all the time. Looks like it. So algebra 2, many functions have a domain of all real numbers. If your graph doesn't have any kind of weird stuff going on, then it has a domain of all real numbers. If every x could be used, then the domain can be all real numbers. So don't think that that you're wrong if you say, well, x can be anything. All right, it's untangled now. See, look, it doesn't even reach over to here. All that was for nothing. The podium blocks the way. How about this? I'm going to, just so you all are aware, sometime during this hour, I'm going to trip over this cord and fall flat on my face. So,
Well, at least you're not. Well, I think you're recording this for no one, but we are missing people today.
We'll see how this works. Now, someone needs to go home and listen to it now. See if it's better.
I'll listen to it at lunch if you have it up on.
I won't. So, why equals 2x plus 3, when I see a problem like this, first of all, I look at it and I say, is there anything that I can see right now in this equation that x would not be allowed to be? I can't think of anything. So then I think about the graph. What would the graph of y equals 2x plus 3 look like? Like a slope line, like this. Can x be any number on a line that has slope? Yeah, you can plug in anything you want, which means the domain of y equals 2x plus 3, or the domain of about any line with slope, is all real numbers. So you have to write this in either set notation or interval notation, which I feel like we should be pretty good at by now. Interval notation, how do we write all real numbers? Negative infinity to infinity. Every single number that you can think of is the domain. If you write it in set notation, we're talking about domain. That was scary. I did that. Then we say x, and since x can be anything, we say where x is a real number. If you want to be real fancy, you could write this. X is an element of, and you make this little fancy E, and then you make an R for the real number system, but you make it have a double line. Oh my gosh. Look how fancy we are. But I'm guessing you'll probably just write this. X is a real number. Right? I'm going to write the top one too, but some people like set notation.
It looks like we're looking at it different, like
It's some math talk there.
it looks like a kindergartner didn't get on my
What about this one? What kind of graph would y equals x squared plus 5x be? A parabola, because it has x squared in it? Yes. So if I have a parabola, no matter where it is, can x be anything on that parabola?
Yeah, good, kind of. Oh, yeah, I was thinking of y.
Y can't be anything, right? But if I keep going here, this is going to keep going out. A lot of times we make our parabola look like they go straight up, but they really get wider, which means any x value you could go up and you could find a point on that parabola, which means what's the domain of that going to be? All real numbers. So I started with these because usually I focus on the ones that don't have a domain of all real numbers, and then people get to ones like this, and they're like, I don't know what to do. If it's a graph of something that you know is a nice continuous function, then it's going to have a domain of all real numbers. Okay? What we want to now focus on is what about if the domain is not all real numbers? And then again, this is kind of just me giving you hints. You don't have to write this down unless you really feel like it'll help you. But when the domain is not all real numbers, or when you look at it and you say, I don't really know what that graph would look like, I'm not sure, look for things in the equation that would cause problems. That means look for things that would make it undefined. So there's a couple big things that should throw up red flags for us as we see these problems. So for this one, g of x equals 3x over x squared minus 4. When you see a fraction, what do you know you're not allowed to have in a fraction? 0 on the bottom. We can have a negative in a fraction, right? But we cannot have 0 on the bottom, because if you divide by 0, your calculator says syntax, error. Divide by 0, error. You can't do it. So when you see a fraction, you have to say, oh, I know the domain cannot have where this equals 0. So to find my domain, I'm going to say the denominator is not allowed, cannot equal 0. And then can you solve that equation? Yeah, sometimes you can just tell by looking, but on this one, to solve that, do you agree I would add 4, take the square root? So x squared is not allowed to equal 4. So if I took the square root, I would say that x is not allowed to be plus or minus 2. Which means x can be anything else, because x can be 0 on the top, x can be a fraction, x can be a negative number. But the only thing x is not allowed to be is what makes the bottom go to 0. So now I have to write that in either set notation or interval notation. This is where some people are going to choose set notation because it actually is a little bit easier. Because guess what? All I have to do to put this in set notation is put the little brackets around it. And I would say my domain is all x's except where x is plus or minus 2. Like x can be anything but plus or minus 2. If you were going to do interval notation, we would want to say everything but positive and negative 2. So think about how we would write that. We would start at negative infinity, and then where would we stop? Negative 2, not including negative 2. And then we'd start right back on the other side of negative 2, and we would go to positive 2, and then we'd skip over positive 2, and we would go 2 to infinity. And technically, we should put those little U's in between there. Kind of forgot. And that's where a lot of people say, I'm not going to do that. I'll just do set notation. And your unit test says write them one way or the other. And I don't care which way. Whichever you prefer. No. It can be a hot mess. Sawyer, this is your answer here. This one. When you see a square root, you should also know that you're not allowed to have certain things under a square root. You can have 0 under a square root, but if you agree, we cannot take the square root of a negative number, or we would have an imaginary number. So this is another one that should go over red flag. If you see a fraction, that's going to not have a domain of all real numbers. If you see a square root, that's not going to have a domain of all real numbers. And so when I see this, I say the smallest this can ever be is 0. So to find my domain, I say that 4 minus 3t has to be, I can't just say can't equal 0. I just say that it's always positive. So what sign could I put here to show that it's always going to be not a negative number? Greater than or equal to 0. That's the smallest that can ever be. So to find your domain, you just set what's under the radical greater than or equal to 0, and that's going to tell you where your domain starts. And again, you just have to solve that. So on this one, I would subtract 4, and oh my goodness, what about this one? If I divide by negative 3, what do I have to remember to do? Flip your sign, so that actually changes that to t is less than or equal to 4/3. And that's because that's a minus 3t. That's what kind of threw us off there. But again, if you do that, you could set your set notation. Oh, not x that time because it's t. Te. Like that. Or this one's not so bad for interval notation. How would you write the interval? Everything less than or equal to 4/3. Positive 4/3 bracket, I guess. Sorry, Trevor, I didn't see your hand up. And again, I don't care either way you do it. But again, the big thing is knowing when you see a denominator, you say it's not equal to 0. When you see a square root, you have to have it bigger than or equal to 0, because then it's anything else in that. And then sometimes they might combine both of them, I think. Ooh, like this one. What if I give you a fraction and a square root? So really on this one, you got to do both things and then figure out if both answers need to be included, because sometimes you can throw one out. So let's start with the denominator part. What can I not have in this problem because it would make my denominator go to 0? 5. You with me on that? If we just set the denominator and we say x minus 5 cannot equal 0, so x cannot equal 5. But that's not the only restriction to my domain, because I also have this square root problem, and sometimes you can just look at it and figure out what's the smallest number you can plug in, but every time it'll work if you just say what's under that radical has to be greater than or equal to 0, and if you solve that, you will get the answer for the domain for that part. And so on that one, if I subtract 12 and I divide by 3, do I get x is greater than or equal to negative 4? And so again, you have options here. Set notation, that's kind of nice because you can just write both of those in your set notation. You need everything greater than or equal to -4, but you're not allowed to have 5 in there. Interval notation you have to think about sometimes, but let's do set notation first. So I could say everything greater than or equal to -4, and I'm just going to put comma, but x is not allowed to equal 5. That's going to be a weird graph if you had to graph that. Someone just threw something at you. Interval notation, if we were just going everything greater than or equal to -4, we would say bracket -4 to infinity, right? But we need to skip over 5. So anybody want to tell me what they think, how we would write the interval notation of that? -4 to 5, and put a parenthesis around it. Skip over 5, and then write what? 5 to infinity. Right, so both of those say the same thing. I don't care which one you use, as long as you write it correctly. So I have some little steps for you. Your book gives you like some guidelines. And again, if you feel good about this, it's up to you if you want to write it down. If you don't feel good about this, these might be some good things to write down to help you. Because your whole homework today, except for 2 problems, the directions say find the domain. That's all you're doing, except for 2 problems. So here we go. Hints for finding domain. The book says always start with all real numbers. Like say, okay, my domain's all real numbers, and then exclude certain things, right? And so the 2 big ones that you're going to see is if your equation has a denominator, I know my shorthand here, but if your equation has a denominator, or maybe if you have a fraction, make sure you set that denominator not equal to 0 and solve it. If your equation has any kind of square root or even root, right? Like the 4th root, the 6th root, the 8th root, anything that has an even root cannot be negative. And so you need to set what's under that greater than or equal to 0. Maybe it would even help on this. You could put like set denominator not equal to 0. And on this one, you set what's under the radical greater than or equal to 0. That's the good for you. What about the cube root? Can the cube root be negative underneath it? Yeah, cube root is allowed to be negative. You can take the cube root of -8. And so a cube root actually has a domain of all real numbers. So any odd root can have a domain of all real numbers, but even roots are not going to. And then I think after the last step, make sure you write your answer in either interval or set notation where you just kind of put those together. So I think maybe I have a couple here that we're going to do on clickers. If I can lose my pen again, it'll be a problem. I think I already started the class, so we'll see how this works. I think I'm going to start setting this out ahead of time. When you come in, I'll say, grab a clicker as you come in. And then you can just put them back in when you're done. I think you can leave the lecture room on. If you don't know your number, I'll put it up here in a second. And when you log in, fix it right here. Yeah. I haven't started the question yet. Anybody need their number? First of all, anybody still writing this? You need me to stop for a second? Alright, fine. I bet that's fun to watch on the video too when we do clickers and it's just like a lot of waste time. Alright. Anybody need their number? Do you need me to show it? Nobody wants to save it. I'll show you anyway for a second if you need it. There you go. 30 through 48. Actually 49. Actually 50. Look. Well, no, look. Well, first of all, Jake, I put backwards. So I put his first name and then his last name in the wrong spots. So it goes alphabetical. And then Dallas added this class late, so he's at the bottom of my grade book. So I put him in last, but I put it alphabetical. So he should be up there. But Jake, I just put his name in backwards. Not Jake's fault. It's my fault. All right. So let me start the question real quick. All right, you're not logged in yet? Try again. See if you can go back. Anybody else still having trouble logging in? Hold on, I haven't started the question yet. I'm waiting for Lane to get his logged in, because I think if I started before he logs in, he can't. Let me just give you another one. Maybe the batteries we have on it. That's awesome. Here, ready for it. You see that works. All right. I don't know. I need a screwdriver to take it off, so I'm not even sure. Okay, so let's start question. See if this works. Please work. That's all it's been doing lately. It's 57% complete. It's not even gonna let me see the answer. Because when it does this, it lets you, like, it has it for you ready to do it now, right?
Yeah.
It's not gonna let me see it though. Which, find the domain of this problem, and notice I wrote it in, interval notation. Let's just do this the old school way here. Raise your hand if you think A is the answer. Raise your hand if you think B is the answer. Raise your hand if you think C is the answer. Raise your hand if you think D is the answer. I tricked you with A there, right?
Yeah.
Because it's not brackets, because 3 is not included. So D is the right answer. I think it recorded your answer if you put an answer in, but I can't see it right now because it's done.
See, isn't that so much easier to policy?
I agree. But let's see if I can do this one. Another test when it's already started. I can't stop it because it won't work. That would take too long. This question has never been started. Well, I know because this is stupid. Okay, let's just do this. We won't even use our clickers on this one either. We'll just do the old raise your hand thing. Which of the following functions does not have a domain of all real numbers? I try to trick you on this one too. Which one does not have a domain of all real numbers? So think for a minute. Get your answer. So that means all of them have a domain of all real numbers except for one. One of them does not have a domain of all real numbers. I tricked you on this. Which one does not have a domain of all real numbers? So I'm gonna give you 4 choices, and then we're gonna all give our answer at once. Okay? So if you think the answer is A, you're gonna stand up. If you think the answer is B, you're gonna stay where you are. If you think the answer is C, you're going to touch your head. And if you think the answer is D, you're going to put a thumbs down. Ready? Go.
I understand it.
I think it's C. I kind of gave you a hint earlier. Why is A all real numbers? Because it's a cube root. Remember, odd roots have a domain domain of all real numbers, so I try to trick you on that. I also try to trick you with D because I threw this fraction in, but can this ever equal 0? No, so if there's just a number in the bottom, it can't ever equal 0. It's still going to have all real numbers. So C is the only one that does not have a domain of all real numbers because it has a square root. Yeah? All right, turn these dumb things off. But like you could still, like if you solved that, there would still be some values because like what if you plugged in 0? You see what I'm saying?
Yeah.
I see what you're saying on there. I thought I was extra tricking you, didn't you? But that is a weird domain. All right, I do have one more thing, so ignore these dumb clickers for a minute. And what if I gave you this problem, which is kind of like yesterday's stuff? Find the difference quotient that is, this is what you have to do on your paper. I want you to take this equation and do f of x plus h minus f of x all over h. And the only reason I'm putting this on there is because there's a question on your unit test of this. This is actually the difference quotient to find the derivative of a function, which is calculus. But we're not finding the derivative because you have to be able to do limits, like we're just doing this. But it's kind of cool when it works out. So it's a lot of algebra, but you just have to watch your signs here. So we just have to do f of x plus h, which is what you should have been doing on your homework yesterday. And then we're going to just subtract the regular function. Subtract f of x, and we're going to divide everything by h. So I just say watch your signs here. So I'm going to go through, and I'm going to plug x plus h in for everything. So I'm going to get x plus h squared minus 4 times x plus h plus 4. That's f of x plus h. And then I'm going to subtract f of x. And if you want, you can subtract everything at once. I'm going to just show my work on this one. But I'm subtracting all of it. So make sure you either change the sign of everything or you put it in parentheses here. So I'm going to subtract x squared minus 4x plus 4. So I got to distribute that negative eventually. All divided by h. And then I just have to do the algebra here. So we have to distribute this, right? We have to FOIL, distribute the negative 4, distribute my negative. So my next line is where like the algebra matters. Watch your signs. So we did this yesterday, but if we FOIL that out, I think we should get x squared plus x times h plus x times h is plus 2x times h plus h squared. Distribute by negative 4, so I get minus 4x minus 4h plus 4. And then I'm going to subtract everything. So then I'm going to subtract x squared minus a negative 4x becomes plus a 4x and minus 4 all over h. And now what should happen is some things should cancel out. Not everything's going to cancel out, but a lot of things should cancel out when you do this. If nothing cancels out, then you probably did something wrong. But plus 4 minus 4 cancels out. X squared and minus x squared cancels out. Negative 4x and positive 4x cancels out. So what's left on top is 2xh plus h squared minus 4h all divided by h. Here's a little trick for you. What's left should all have h in it that you could factor an h out of every time. Okay, so that's kind of what should happen every time. Everybody with me to that point? So my last step is notice now everything has an h in it that I can factor out. And I have 2x plus h minus 4. And can I now cross those h's out? And that would just be 2x plus h minus 4. And that's where we're leaving it because we don't know calculus. So Rachel, try not to take the derivative of this when you get to this point.
Is there going to be one?
2 under homework like this.
That's nice.
There's one on your unit test like this. So how about I not teach it to you and then you take the unit test and you say, why didn't you teach me this? Right? It's not that bad. It's just a bunch of multiplying out, right? It just looks ugly. All right, so I'm gonna come around and get your clickers. Everybody done write this down? And this is your homework. 47 through 60 all. The directions on 47 through 60 say state the domain. So sometimes it's all real numbers. You're not gonna have to do anything, and sometimes you're just gonna have to look at the denominator, look at the square root, and then 77 and 78 are like the ones we just did. You should get stuff to cancel out. You should be able to factor an h out and cancel that h out every time. It is a lot of problems, but they're not so bad.